In this example, we're going to find the exact value of an inverse trigonometric function. What we have is the sine of the arctangent of 1/2. The first thing that we're going to do is concentrate on the expression in the parentheses. The arctangent, or the inverse tangent of 1/2, we're going to say is going to be some angle theta, so that theta equals the inverse tangent of 1/2. Remember, what that means is that the tangent of some angle theta is going to equal 1/2. Now, what we should recognize is that the angle theta is going to be in the first quadrant. Why do we know that? We know that because the restricted domain of the tangent function is all real numbers between -pi/2 and pi/2. Because the tangent is positive, I know that my angle theta is in the first quadrant. So what I'm going to do is draw a picture that represents this situation. There's my angle theta in the first quadrant. Because the tangent of theta is 1/2, the side opposite theta is going to be 1. The side adjacent is going to be 2. In other words, this point in the first quadrant is 2, 1. So what's the distance from the origin to the point 2, 1? Well, the distance r is the square root of 2 squared plus 1 squared, or the square root of 5. So I have the hypotenuse, if you will, of this triangle is the square root of 5. So theta has as its side opposite 1, its side adjacent 2, and its hypotenuse the square root of 5. So when I'm computing the sine of the inverse tangent of 1/2, what I'm really doing is computing the sine of this angle theta. Well, the sine of an angle theta is going to be the length of the side opposite over the hypotenuse. So that's going to be 1 over the square root of 5, which, if I rationalize, is root 5 over 5.